it's Monda Tutoha, and this is my submission for the PDE3432 LABVIEW assignment. The task was to design a manipulator arm using LABVIEW, and that it must be mounted on top of a turtle bot, and then the arm should be able to pick up stuff from the ground, and then it should be able to place it into 3 different shelves with measurements of 200 millimeters, 400 millimeters, and 600 millimeters in height. And so what I came up with is this simple LABVIEW in the middle. This is a demonstration of it. First thing first, we'll go into a home state, which I have programmed and I will explain later. And then you'll go to pick up. It will then pick up the things and then go back. You can change the speed of how fast the manipulator moves by just changing the meter. You go to the bottom shelf, the middle shelf, and then the top shelf. These scales here show the joint position. As you can see, only 3 or 4 of them move, and that's because as I'm using 6 degree of joints, I'm only using 6 joints, I'm not using 4, and so to do this movement, only 3 of them require movement, as we're not moving the y-axis, we're only moving through the x and z-axis, which is why not all joints are moving. I'll show another quick demonstration, make it faster. You pick up bottom shelf, middle shelf, and then top shelf. You then stop, and as this side of demonstration is done, I will show the background. This is the block diagram. As you can see, this is my DHF parameters. I'm using 6 joints, which is why I've only changed the twist on the first, third, fourth, and fifth. The second and the last one are as they're joint with both the first and the last pickup, so there was no need for the twist angle to be changed. And then these are the lengths and the offset of length used. These here are the current joint position, which is the home state for it. What happens is we'll go through initialize, we get the arm, we initialize it, and then we plot it, and then we get the reading into the forward kinematics, where it applies the current joint positions. I then take the reading into the Cartesian, and then I let it be known that I have 3 different or 4 different positions that I should go to. These are the positions here: 0.4 millimeters, 0.6, 0.2, and then minus 0.2 is the pickup, which is where it goes under, and 0 is the home, that it always goes after picking up. Then the Cartesian is where it shows the steps. As you can see, this is where the meter is put. The way the meter works and how it changes the speed is basically by reducing how many steps the Cartesian takes, and so the more steps it has, the slower it will be, as it will perform more and more steps, and then the lower it is, the faster, which is how the meter and the speed of the simulation works. I then take it through the inverse kinematics. I then let it be known that I'm only using the x and the y, as this goes x, y, z. I turn the x and the z on, and then the raw, pitch, and yaw is not needed for this, and so that's why I've only used the x and the z. I then plot it and show it into a 3D picture. I'm using shift registers so it keeps going back and it keeps selecting the right one that I tell it to do. And yeah, that's basically it. Thank you for watching.